Now we're going to look at factoring polynomials. So to begin with, let's look at what exactly we mean when we say to factor completely. Factoring a polynomial expressed as the sum of monomials means finding an equivalent expression that is a product. In other words, we're going to take 3x squared plus 5x and turn it into a multiplication problem. The goal in factoring a polynomial is to use one or more of the factoring techniques until each of the polynomial's factors, this multiplication product, each factor must be prime or irreducible. The only exception to that may be a common factor, a simple monomial factor. In this situation, the polynomial is said to be factored completely. The first and most basic method that we have of factoring is a greatest common factor. It will be abbreviated, the GCF, throughout so much of everything that we do. It is an expression of the highest degree that divides each term of the polynomial. If there is any term in the polynomial that it does not divide, it is not the greatest common factor. It must divide each term. So, for example, factor out the greatest common factor of 10x cubed minus 4x squared. Well, first I find the greatest common factor of 10 and 4, which is 2. Then I find the greatest common factor of the x's. In essence, that turns out to be the least exponent. Then I open parentheses and divide it out of each term. 10 divided by 2 is 5. And when you divide with a common base, you subtract your exponents. So 3 minus 2 is 1. I have an understood exponent of 1 on my x. Minus, comes on down, 4 divided by 2 is 2. And x squared divided by x squared is 1. So my final answer, notice what I have now is a multiplication problem. It is 2x squared times this binomial. I turned a subtraction problem into a multiplication problem. That is what it means to factor. Let's try that one more time to make sure we understand it before we go to something a little bit more involved. I have a sum, 9y to the 5th plus y squared. I need to factor the greatest common factor, and in doing so, turn it into a multiplication problem. Well, my greatest common factor of the coefficients, I have an understood 1. Greatest common factor of 9 and 1 is 1. But for my variables, since both guys have a y, I choose the least exponent. Then I open parentheses and I divide it out of each one. 9 divided by 1 is 9. When you divide with a common base, you subtract the exponent, so 5 minus 2 is 3. Plus sign comes on over. 1 divided by 1 is 1, understood. And y squared divided by y squared is also 1. Please, if all of your variable there becomes a 1, you must then express the 1. Do not leave it out. Y squared times 9y cubed is not equal to this whole thing. It's just equal to 9y to the 5th. So be sure, if you divide out the entire term, that you do express that 1. Okay, let's take a look at a trinomial. Factoring out the greatest common factor is going to still work in identically the same way. So I'm going to find the greatest common factor of the coefficients. 16, 8, and 12. Greatest common factor is going to be 4. I look for the x's, but this guy does not have an x. So x is not going to be part of my common factor. But all three guys do have a t, so t is going to be part of my greatest common factor. My least exponent on t is 1. So 4t is my greatest common factor. So I open parentheses and I divide it out of every term. 16 divided by 4 is 4. The x squared was untouched, and t divided by t is 1. So 4x squared times 1 is 4x squared. Plus 8 divided by 4 is 2. The x was untouched. T divided by t is 1. 2x times 1 is 2x. And finally, my third term, 12 divided by 4 is 3. T divided by t is 1. And 1 times 3 is 3. Now, if as you're doing this, you have any self-doubt whatsoever, use the distributive property to multiply it back out. You'll end up exactly where you started. But be sure that you know this is your answer. I've had students in the past who multiplied it out to check it and gave me this as the answer. Be sure if you do check that you still give me the correct answer. And another trinomial to make sure we're all on the same page. Factor out the greatest common factor. 6, 9, and 18. I think my greatest common numerical factor is going to be 3. X, X, no X. So there's no X in my common factor. Y, Y, Y. All three guys have a Y. So Y will be part of it. And I choose the least exponent. So from 3, 4, and 5, I choose 3. Then I open parentheses and divide it out. 6 divided by 3 is 2. X squared was untouched. Y cubed divided by Y cubed is a 1. So I put down my plus sign and I go to the next term. 9 divided by 3 is 3. X was untouched. Y to the 4th divided by Y cubed is Y to the 1st, because 4 minus 3 is 1. Then plus 18 divided by 3, I do believe is 6. Y to the 5th divided by Y cubed, 5 minus 3 is 2. So that's going to be Y squared. And this is my final answer. Again, I can multiply it back out if I'm at all uncomfortable with it. Now, let's take a look at a little twist. It does not have to be a numerical or a single variable common factor. In this case, I have a common factor of parentheses. What's inside parentheses is identical. They're both x minus 7. So my common factor is the parentheses. So I write my common factor down. I open parentheses and I divide it out of each term. So 2x divided by 1 is 2x, and x minus 7 over itself is 1. Plus 3 divided by my understood coefficient 1 is 1, and x minus 7 over itself is 1. My final answer. And one last example of factoring out the common factor, just to make sure we can put it all together. Numerically, look at the coefficients. 14, 28, 7. Greatest common factor would be 7. Look at the m's. All three terms have an m. And the least exponent is 2. Look at the parentheses. All three terms have a parentheses, and that parentheses has the exact same thing inside, m plus 1. So it also is part of my common factor. So then I open parentheses and I divide it out. 14 divided by 7 is 2. M to the 4th divided by m squared is m squared, because 4 minus 2 is 2. And m plus 1 over itself is 1. So bring down my minus sign. 28 divided by 7 is 4. M cubed divided by m squared is m to the 1st, because 3 minus 2 is 1. And parentheses over itself was another 1 to multiply by. So minus sign. 7 divided by 7 is 1. M squared over M squared is 1. Parentheses over itself is 1. So I am left with 1 times 1 times 1, which is 1. Okay. Why did I show you this example? I really feel like I need to say this because so many students turn this into something way more difficult than it has to be. Many students would begin by multiplying through those parentheses, distributing through and then collecting like terms, and then you've got this awful mess to try to factor. Don't ever overlook common parentheses. It will make your life easier.